Evaluating solvable groups of trigonometric integrals, specifically powers of sines and cosines. So this time we'll be dealing with those integrals in which none of the exponents of the sine function or the cosine function is equal to 1, but one of them or both of them are odd exponents. So in the case here, we have an even exponent for sine of 4x minus 5, and we have an odd exponent for cosine of 4x minus 5. So take note, these are two functions with the same angles, but they have different exponents. So because we are looking at the odd exponent, what you want to do in this case, because we cannot use the integration by simple substitution directly here, what you want to do here is to transform this into a form wherein we can perform integration by simple substitution. So what we will do is to simply copy the function with an even exponent, so that's sine squared of 4x minus 5, and subtract 1 from the odd exponent. So we have 3 here as an odd exponent. We're going to subtract 1. So that would make it cosine squared of 4x minus 5. So remember, we are not going to change the given. We're just going to express it differently. So why are we subtracting 1 from the odd exponent? Because what we want to do is to separate it. So we're simply going to factor 1 out. So we just write here cosine of 4x minus 5 dx. So why are we isolating this cosine of 4x minus 5 here from cosine cube of 4x minus 5? So take note, if we multiply these two again, we get cosine cube of 4x minus 5. We are isolating this because we want to be able to use integration by simple substitution. So by isolating this should be our du later on when we perform substitution. So if this would be our du or part of our du, the cosine function is our part of our du, then everything here in the integrand must be expressed in terms of sine. Okay? So we already have sine squared here, 4x minus 5. This cosine of 4x minus 5 is raised to the power of 2, so we will use the Pythagorean identity to express that in terms of sine. So we can rewrite that as sine squared of 4x minus 5. And remember, sine squared u plus cosine squared u equals 1. So if we want to express cosine squared u in terms of sine, that's equal to 1 minus sine squared u. Okay? So this cosine squared of 4x minus 5 is equivalent to 1 minus sine squared of 4x minus 5. And then copy cosine of 4x minus 5 dx. So what we have here, we have cosine 4x minus 5, and everything else here is already expressed in terms of sine. Therefore, we can now proceed to performing integration by simple substitution by letting the other function, that's sine of 4x minus 5, be equal to u. So that du is equal to 4 cosine of 4x minus 5. Don't forget your dx. So this is what we isolated in our integrand. So cosine of 4x minus 5 dx is equal to du over 4. So substituting, sine of 4x minus 5 raised to the power of 2 is u squared. times 1 minus, so this is 1 minus sine squared of 4x minus 5. So that's 1 minus u squared. And cosine of 4x minus 5 dx is du over 4. So that we can just put 1/4 outside and distribute u squared, which gives us u squared minus u to the power of 4 du. Then we can proceed to integration. So that's 1/4 times u cubed over 3 minus u to the power of 5 over 5 plus c. Or that would be 1 over 12 u cubed minus 1 over 20 u to the power of 5 plus c. And then we have to write it again in terms of the original function. So that's 1 over 12. Our u is sine of 4x minus 5. So the sine cube of 4x minus 5 minus 1 over 20 sine to the power of 5 of 4x minus 5 plus c.